All right, so we are on the OnShape practice exam, the third portion, which is our assembly portion of the OnShape associate practice exam. And so in this practice part, we are going to be assembling this locking plier assembly. And so they gave us this starting document. We made a copy of this. So if you haven't done so yet, just click to make a copy of this. And they already have all the parts in here. So our task is going to be to assemble them according to these instructions. They give us an exploded view. If we could just kind of read through it, these different views are showing us different views in which each part is going to be connected together. When it says coincident, that means that those parts are touching another part. And then if we scroll down to the bottom, we see that the upper jaw and the top handle do not move, and that all holes are concentric on the pins, meaning they have the same centers. So those are some important instructions. The other thing I want to point out is, on this quantity, that each part is placed one time. If a part was placed more than once for another file, you can just hit insert and click it a second time. Okay, then when we read through these instructions, the instructions tell us to open the starting document and the instructions, go to tab 10, and then, or question 10, and then make sure that all components have the correct material. So you may want to go ahead and do that, right click, edit material, and just verify that each material here matches up with the materials over there. They do, because we're using their starting document, but that'll kind of ensure that you are using the starting document. And then they give us a few other instructions down here. They say that when the locking pliers are closed, the front of the upper and lower jaws will be coincident. That's this gray and blue jaw here. Then the lower jaw can rotate 30 degrees to open. The handle link is centered on the pegs, and there are no interferences in the assembly. Okay. So I am going to go ahead and get started. We're going to go over to an assembly tab, and we are going to click on insert. You can do these one by one, or you can just click the entire locking plier parts file, and they will all be inserted in. We're going to hit the check mark. And because it told us way at the bottom that the upper jaw and the top handle do not move, I'm going to choose one of those to be my fixed part. I'm going to choose this upper handle here. You may want to click on it, make sure it says, top handle. So we're going to right click this and click fix. And now this part will not move. Everything else can move, but this part's going to be locked in place. I'm going to actually start off with the upper jaw because that's the other part that doesn't move. So I want to get this inserted kind of up here somewhere. And so when I look at this, you can kind of see that this is lined up here. And I'm going to scroll up just to kind of look at everything. I see the coincident markings and this upper handle right here. I see this exploded view line. This axle is kind of going through this first hole, right? So we got that first hole up there. So I want basically this piece here to be able to be inserted into this hole. Okay, so there are a couple different ones we can do. We can do a fasten mate because we don't want it to move at all. We can do a revolute mate. We can do a cylindrical mate. I like cylindrical mates a lot of times for circles. However, in this case, a revolute mate is actually a pretty good idea because what a revolute mate will do better than a cylindrical mate is it will not allow our part to move. So if we choose a revolute mate, I'm going to choose this circle right here, and I'm going to choose the far left part. We could choose the middle as well. Yeah, we can go with the middle. So I'll choose the middle there, and then over here in this circle here, I want to make sure I also choose the middle. So if I go to this circle, you can kind of see it's a little tricky to find. I'm right clicking, by the way, to rotate my view. So we can see when I go into the circle, there's the left, there we go, the left, the middle, and the right. So that's the middle. So I went middle with middle, and then I hit the check mark. When I go middle with middle, I always click this X up here so I can kind of see what happened. And that looks correct. If I try to drag this, it will not go left and right. It does rotate, but if I kind of look at this front view, the X plane is left and right. This will not go left and right. Had I chosen cylindrical, it could still go left and right. So that's why I thought Revolute was a little bit of a better choice here. Now it does rotate up and down. We don't want that to happen. So I want this to kind of stop when it gets right about there. If I'm looking at the right view, right when it gets about there. And so initially I thought this might be a planar mate, and I tried to do a planar mate with this surface and this surface over here. That gave me an error, so I tried a slider mate, which is very similar to a planar mate, which is for parts that kind of can move forwards and backwards. And so this one actually did work. So I did a slider mate, and I said, I want this face here to be kind of matched up with this face over here. And that ended up working out. And as soon as I did that, I hit the X. Now this is locked in place just how I want it to be. All right, so now we are good with the upper jaw. And now we're going to move on to the lower jaw, which is this blue part. And so if we look at this blue part, it is showing that the top hole is lined up with this circle up here. So this top hole is lined up with this blue circle right there. And that's actually going to be this hole right here is lined up over here, right? Because it's the one, this top hole is the one with the kind of even with the teeth of our jaw. If you want to, this is something that's totally not necessary, but if you want to, you can click this and you can click on this top thing to top little button to rotate. And I'm going to rotate this at 90 degrees. And all that's going to do is just make it so it's kind of already lined up there. It's totally unnecessary, but sometimes it just makes it easier to see. So I'm going to choose that same revolute mate. And I want to go in here and I'm going to do the same thing. I have, when I go into this cylinder, I have the back, the middle, and the front. I want to choose the middle mate connector. I'm going to right click and hold down. And I want to look underneath this part so that I get this middle rod right here. And I want to choose again the middle mate connector. I'm going to hit the check mark and then I will just exit out of this. And then I'm going to go back to kind of a default view and just check, click and drag, make sure this is working properly. That's what I want it to do. So I'm going to actually right click on this Revolute 2 and rename it Revolute 2 for the lower jaw. And that's because I think that later on, this might be important to remember this one for that 30 degrees that it mentioned. Next up, we can do this bottom piece right here, which I think they call they call that the bottom handle. So the bottom handle, there are two rods in here. There's this front rod and then this middle rod. If we go back and we look at, especially the exploded view is a good one, is the lower jaw. If we zoom in here, the lower jaw has a line, an exploded line going to that front rod. So that's where I want to connect that lower rod with. So I'm going to do the same revolute. I'm going to come in here and basically do the exact same thing we did before, is get this middle, I usually have to rotate a little bit to get where I want to. So I want this middle mate connector. And then I'm going to rotate, and I want to make sure I'm on the front one, not this one up here, but the front one right here. So that middle one. And then we'll hit the check mark, and I will come out and make sure that this is how I want it to look. So I can drag this. This rotates up and down, which is good. And this still can rotate up and down. This is not moving together yet because we haven't attached this handle link. But once we do that, everything should start to move together. So I come back here. The next one is the handle link. This is attached to both the upper part and the lower part. And so we're going to go ahead and work on that. And I do want to make sure it looks in the same orientation, right? The shorter part is kind of going down. The longer part is going up. And that is how it looks right now. So I'm good to go. So I'll do the bottom first. And we're actually going to just keep doing the same revolute mate. It's kind of using this one over and over in this assembly. And so I'm going to go to that middle, same exact thing we've been doing, is try to get that middle mate connector. And then over here, I want, again, the middle mate connector of this guy. All right, so we're going to hit the check mark. And we're going to do this one more time. I want the middle mate connector for the top. And if I rotate up here, let's see. Where are we on this one? You know what? This may actually be part of the pin. Yeah, this is part of this pin. So there is this other piece called the, what do they call it? The screw adjuster. Okay. So since, I thought there was going to be something up here, but there wasn't. So it's actually going into this screw adjuster. So I'm going to actually hit the X right now, and we'll save that for later. So this can go up and down. They move together. this screw adjuster is going to kind of come in through the top, and then this link will go there. So I'm going to actually focus on this guy first, then we'll come back to it. So our screw adjuster is going to go through the back side, and if we look down here, let's see, there we go. It is showing right here kind of that it is the end of that circle is lined up right with the end of the part. And then we should get here we go. We get a section view over here that's kind of showing this view. So we want to start attaching this. So in this case, I do want it to kind of come in here. And so I will do a cylindrical mate this time because I don't want to be rotating it back and forth. I just want the centers to be lined up. So I'm going to do a cylindrical mate, and I'm going to pick basically anywhere on the cylinder. It doesn't really matter. I'll choose the middle. And then if I come here, this hole, same thing. It doesn't really matter in this case, front, middle, or back, because we're just lining up the centers with the cylindrical mate. So I'll hit the check mark. And now this can go forwards and backwards. And kind of same thing. It can rotate. You want to watch out for that. It can rotate. And we are going to want to fix that so that it's not rotating. Next up, I want to make sure that this is basically pressed all the way forward. So I usually like to do that with a planar mate. So we'll find our planar mate. There's probably an easier way to do this, but this is how I've always done it. So I'm going to choose this surface right here, that flat surface with the flat surface of this blue part of the, this circular shape. And I'll hit the check mark. And so now it looks like it's not moving at all, but it actually is. If I go to the bottom, when I move this, it's actually still rotating. So I want to make sure that that is no longer rotating. So what I kind of noticed, what we're a little bit lucky with, is this is a flat surface here, right? And when I have this guy's kind of in the way, but if I zoom in here, this flat surface is actually, going to be parallel to this flat surface when I have this straight up and down. And that's where I want it, right? I don't want it over here because we want it kind of just like that so that this yellow or orange connector can come in there. So to prevent it from rotating, what I am going to do is I'm going to choose the parallel mate. And I want this surface here to be parallel with that surface there. I'll hit the check mark. And that worked out for us, hopefully. You know what? That did not actually. So let's undo that one. I have picked the wrong surface. So let's try that one more time. So we want parallel. Let's see. I may actually be missing this. If I hit, let's do this. This is kind of a trick. If I don't want to be able to see this guy here because it's blocking me, this bottom handle, I can right click it, click suppress, and that'll just hide that from us. And then I'm going to do the same thing with the handle link because that's just in my way right now. So if I zoom in here, oh yeah, that is not parallel. So what I actually want is I want this bigger surface. That's the surface that should be parallel. So I want to pick this bigger surface. I want this guy to be parallel with that guy. I think that should work. There we go. Yep. So now if I look at it, if I try to drag this, it will not drag. It is locked in place. So now I can unsuppress these two guys so that they are visible again and they're appearing. And now I have everything where I want it to be. So now our next place is to go back to this link connector. And we're going to link this guy up with that circle right there. So we're going to go back to our revolute mate. And we want to go to the middle portion of this cylinder or this hole. Again, sometimes you just have to rotate a little bit to be able to click the right spot. I'm going to come up here, and again, I want the middle portion, and I'll hit the check mark. And so now we should be able to drag up and down. And if we go back to our isometric view, I like to hit Shift F7 to go there. If we drag this, we can see everything is moving together, which is nice. So now I pretty much have everything where I want it to be except for this cover piece, this grip. And I notice when I come back here, the grip looks like it's on the end. Let's come back here. Yeah, it's kind of on the end there. It's showing coincident with the back. So this is kind of how I want to see it. So same thing I did before. You don't have to do this, but I like to, kind of click here and rotate this. I'm going to rotate it 180 degrees so that it's basically just kind of facing in the direction I want to. If you want to, you can also rotate it That would be the wrong one. Do that. Rotate it. Let's rotate. There we go. We could rotate it up just a little bit so it's kind of pointing in the right direction. So this is kind of the alignment we're going to want. And the first thing I did is I just kind of came over here and I wanted to click on this back view so that I could see them this way. And that just helped me out a little bit so I can see them from behind. And what we want to be able to do is we want to place basically this gray piece is going to be flush with this piece over here, right? If we look at our instructions, you can kind of see that the yellow and the gray are flush together. So I did a planar mate, right, with this, basically this front view. It doesn't really matter which one of these mate connectors as long as I'm on that front surface, that front face, and this front face here. And that is flush, right? If you click on these, it might change it, but this is flush. That's what we want. So I'm going to hit the check mark. And that is good right there. I'm going to hit the X. Now, this doesn't look like it did anything, and it's kind of nasty, but it did. If we go to the back view, what you'll see is not a whole lot, but if we go up to the top, or really the bottom, I guess would be better, is you will notice that this piece should be kind of lined up together, right? So we have it flush there. Now, the next thing I want to move this so that it's kind of inserted in there. And what I noticed in here was when I came over here, there is kind of some circular portions. There's a circular shape in there. So I did a cylindrical mate again. I said, hey, I found a circle right in here. Let's see if we can find it. All right, there it is. It's kind of tricky to see. It's this right here, that little bar right there. So you got to be on that little half circle. So if I click that half circle right there, I want that half circle to be lined up cylindrically with this one right here. I'm sure there are different ways you can do this, but as soon as I do that one, now I've got this locked exactly where I want it, right? And that made it perfect for me. Now, there are definitely other ways we can do this with planar mates, right? You could do some planar mates with maybe, the left side, right? Maybe kind of doing something with this left side and this left side. That could work. And then you'd have to do something kind of up and down, right? Because it still might go up and down. But this one worked for me, and so that's kind of what I did. So now I have everything how I want it to be. And when I look at this, the tool is able to move up. It is kind of passing through this, and then it's moving down. They did talk about wanting a 30-degree limit. And so I went back here to this one that I talked about, and I double-clicked this, and I went to limits. And the problem that I ran into was that 0 is actually right here. And so when I kind of started to drag this, what I noticed is this is what really we want to call 0. And I'm seeing it at about 348 degrees. You might get it at 12, right? That would be the opposite. And so really, it's kind of, in my opinion, I think it might be 12 to 42 is what you might get. Or if you're backwards, it looks like I'm backwards, then you might get negative 42 to negative 12. Seems kind of weird. I'm not even sure if that's it, to be honest. So I know I was just running into some issues, and so I decided to actually kind of just go with 0 and 30 for right now, and delete it later if I need to get it to be larger than what I wanted. So I just went here when I went to limits and I typed in 0 and 30. This was going the wrong direction. So I tried negative 30 and 0. Your 0 and 30 might work. It really just depends on how you lined it up. And that does sort of work for me. But again, that looks like it's kind of going the wrong direction. So I'm not quite sure. We may get rid of that later. Okay, but at least right now, If I try to drag this, we can kind of see that it's opening up at least some portion. It is going over. That's kind of talking about maybe the interference, but I'm not going to worry about that right now. I'm going to just start trying to answer these questions. So in question 1, they ask us to position the assembly in the closed position and then use the mate connector provided to evaluate the mass properties. So we're going to go ahead and do that. We are going to get this closed. So if we drag kind of all the way up right there, and I'm going to just click on the right view, we can get this closed. Now what I want to make sure I do is I don't want this to cross in, right? So I want to get basically right about there. And I kind of noticed that these two lines look parallel. When I look at the picture, right, that's what's showing is those two lines are parallel. So that's what I'm trying to get it in that closed position right there. And so once I have that, I am going to click this mass properties button. And it's saying which parts do we want to measure? Well, I just kind of zoomed out and I just selected everything. Right? I want to measure all of this. And right now it's not, it's going off of the origin. If we look here though, it says use the mate connector provided on the locking pin. So it's in the second part that we want to do is where it says mate connectors to reference. Instead of measuring from the origin, because everyone's going to have a different origin, they want us to measure from this mate connector because everyone will have the same mate connector. So when we click on that, now this X, Y, and Z axis change. I'm getting a Y of negative 16.27. And they asked us to do the Y direction center of mass. So when we go back up here, we see negative 16.217 and negative 16.25. I had negative 16.27. And remember, I was kind of trying to play with exactly where I thought this might be. If I go right about here, which I think looks kind of right, I think then we get we're going to mate connector again. We get negative 16.26, right? Negative 16.26 is definitely closer than negative 16.21 or 22. And so that's probably our best choice. There's likely a better way to do this to make sure that it's totally closed. If you have a better way to make sure that you're seeing where it's totally in the closed position, leave a comment, and that should help some other people as well as myself. But that's what I did for right now. I'm going to do the other parts in a follow-up video. Those are all very, very quick. It should only take about 2-3 minutes to do all of those.